Hello, my name is Jonathan Bisnet, and this video is going to show you a waveform generation circuit. It's driven with a microcontroller, in this case a Zilog EZ8, a Z8F6423. This is an evaluation board, and what you'll see here on the back is I've connected a number of the output ports, and there's roughly 56 of them. I've connected them with a 40-pin ribbon cable to a breadboard. Several of the ports are used to drive the LCD display, which you'll see here. And then a few additional ports are used to drive the R to R array, which will generate the 0 to 255 discrete voltage levels that show the waveform on the oscilloscope. And finally, there's a 4-switch dip here, which allows me to select one of the 4 waveforms to be generated. Finally, there's a 5-volt supply here to use to drive the LCD display. The microcontroller runs at 3.3 volts, and they share a common ground. If I go ahead and click the first switch here, you'll see that it's going to generate a sine wave, which you can see on the display here. All 4 waves are running at roughly 100 hertz. This one's a little rough because it is only 100 hertz, and it's using 72 points to generate that waveform. If we go back and turn that one off and turn the next one on, you'll see we're going to now generate a sawtooth wave. Now this wave is generated using an 8-bit register. It basically starts at 0, counts to 255, and once it hits 255, it rolls over again, basically giving you that waveform. Like in the case of the sine wave, we used a table lookup to generate those, to go from midpoint to high, back to midpoint, down to 0 and back. Doing all of that as a series of lookups to do it rather than using a register like we did here in the sawtooth wave. If we turn that off and turn the third switch on, you'll see we're now going to generate a square wave. This is probably the easiest of the 4 waves to generate. You're simply oscillating between 0 volts and 255 value, which is roughly 3.3 volts. So you can see it going back and forth roughly half the time of the wave. Finally, the 4th switch, if we turn it on, we're going to generate a triangle wave. This one is similar to a sawtooth. It goes from 0 to 255 and back to 0 in the 10 millisecond period for the waveform. Again, 100 hertz. So it's pretty straightforward how this one works using that same 8-bit register. Finally, if we turn on more than one switch, you'll see that it reports that situation, more than one switch selected, and it actually generates no output. It turns off all the waveforms. When you turn the extra one off or whatever, it'll go back to whichever waveform is left. And then finally, if you turn them all off, it generates no waveform at all. That's basically how this particular circuit works. The code is all written in assembler, and I will post it online. It actually includes a fair amount of advanced assembler. Anyway, I hope you found this circuit interesting. I intend to do some more here in the near future. Thank you.